So let's try to solve this question. So in this question it's been asked that a hydrocarbon contains 82.8% of carbon, and this asked that find its molecular formula if its vapor density is 29. Okay, and the atomic weights of hydrogen and carbon given, which is 1 and 12 respectively. Okay, so it's very simple that it says that it's a hydrocarbon and it contains 82.8% of the carbon. That means the remaining is the hydrogen. Okay, because it's a hydrocarbon, hydrogen and carbon. So if 82.8% is carbon, remaining percentage, which is 17.2%, would be the definitely hydrogen. And they are saying the find its molecular formula if its vapor density is 29. So it's very simple. First we what are we gonna do? We're gonna form the table consists of element, percentage composition, atomic weight, then relative number of atoms, and final simplest or simple ratio. Okay, the elements is definitely the carbon and hydrogen, or you can say hydrogen and carbon because it's a hydrocarbon. Percentage composition of carbon is given, which is 82.8 percentage, whereas when you subtract 82.8 percentage from the 100, you get the answer is equals to 17.2 percentage, which is nothing but the percentage composition of the hydrogen, 17.2 percentage. Atomic weight of carbon is 12 and hydrogen is 1. We have to calculate relative number of atoms, which is nothing but the we get when we divide the percentage composition by atomic weight. So it's gonna be 82.8 divided by 12, and over here it's gonna be 17.2 divided by 1. So answer is gonna be equal to 6.9, and over here it's gonna be 17.2. So what do we do when we get the relative number of atoms? We divide the all the relative number of atoms by the smallest number in the relative number of atoms. Okay, so over here it's a 6.9, so we're gonna divide 6.9 by 6.9, which will end up become 1. And when we divide the 17.2 by 6.9, answer comes out to be 2.5. Okay, now it's very important that it's a fraction. Okay, so I would say the ratio is carbon is to hydrogen is equals to 1 is to 2.5. Okay sir, first of all there cannot be fraction over here. Okay, it cannot be in the form of decimal. Okay, but can I write 2.5 as a 5 by 2? Correct, for the simplicity. Okay, can I write it? Yes, definitely I can write, because 5 by 2 is nothing but 2 to the 4 and 1 remaining, which is decimal point 5. Okay, so I can write 1 is to 2, 1 is to 5 by 2. Okay, now if I want to remove this 2, what should I do? I should multiply both the sides by 2. Correct? Yes. So 2 into 1 is 2, 2 into 5 by 2. Okay, so 2 and 2 gets cancelled. We end up being 2 into 1 is equal to 2 is to 5. Okay, so ratio becomes 2 is to 5. So carbon is to hydrogen are in the ratio 2 is to 5. Therefore my empirical formula becomes equal to C2H5. Am I clear over here? C2H5. Okay, so why are we multiplying it with the 2? Because we want to get rid of this fraction. Okay, because atoms cannot be in the form of fraction, they has to be in the simplest ratio, simple whole number ratio. They has to be in the simple whole number ratio, which is 2 and 5, and they cannot be in the form of like 5 by 2 or 1 by 2 or 1 by 3, something like that. Okay, so now we have the empirical formula. We can move forward towards the molecular formula. As we all know, the molecular formula as a formula is equal to n into empirical formula. Am I right? Yes, correct. And we know the empirical formula we have over here. We can substitute over here, but we do not know the value of n. How can we calculate the value of n? So formula is n is equals to molecular weight divided by empirical formula weight. Now do we know the molecular weight? So nope, the molecular weight is not given, but the vapor density is given, which is 29. That means if I multiply this vapor density by 2, then I'll get the molecular weight. So when I multiply 29 by 2, I get the answer is equal to 58. So my numerator is set which is 58. What about my denominator? So that definitely we have the empirical formula over here, which is C2H5. So we just have to add all the numbers. So empirical formula weight is equals to 2 into carbon plus 5 into hydrogen, which is nothing but 2 times 12 plus 5 times 1. Okay, so for answer becomes nothing but the 29. Okay, 12 to the 24, 24 plus 5 becomes 29. Okay, so denominator is 29. So 29 2s are 58. So my value of n is 2. Okay, so now my molecular formula is equals to n into empirical formula. What is my empirical? First of all, what is the value of n? We just calculated, it is 2. So 2 into empirical formula. What is my empirical formula? C2H5. So answer would become equal to C2H5. 2 into C2H5 would become C4H10. C4H10. Okay, so our molecular formula is C2H10. Let's once again go through this question. So it was simple. It was asked that it's a hydrocarbon. It contains 82.8% carbon. That means remaining 17.2% is our hydrogen. Okay, it when asked that find the molecular formula if its vapor density is 29. Okay, so we first of all calculated the simple ratio by dividing the percentage composition by atomic weight, and then dividing the relative number of atoms by the smallest digit. Okay, then as we saw that it is fraction over here and fraction cannot be over here, so what should we do? We should get rid of this fraction by multiplying the appropriate number. Okay, so it was 2 over here, so when we multiply 2 over here, we get rid of this 2 and the simplest whole number ratio becomes 2:5. Okay, and hence the empirical formula was C2H5. Then we calculated the value of n by dividing the molecular weight by empirical formula weight, and we got the answer is equals to, when we multiply this 2 to the empirical formula, we finally get our molecular formula, which is nothing but C4H10. Now once again, if you have any doubt regarding this question or any other question, you can comment your doubt into the comment section and we'll try to make the dedicated video towards your doubt. Till then, keep on studying.